Okay, for the record, let's make sure everything's correct. We're working on the Zodiac table. Our go live notification says we're working on the Libra symbol, video 192. Zodiac table, Libra. Okay, it's Thursday, it's video 192 because the previous was 191. So, and... Yep, okay, I think that's good. We can also double check the old video for a second. I want to double check the previous video and make sure that was actually video 191 previously. And then we're going to get to coding. So here's the previous video in our archives, and that says 191. Okay, cool. So let's go work on the next symbol. So within the code, we're going to go into the cutting sheet thing, right? And we're going to just add the thing for Libra, right? We're going to start stubbing some stuff in. And we might not get to actually writing any code because... so there's the possibility that we're going to run out of some time because I have some food in the oven that's almost done. So this thing here where we have VIR for Virgo, this is going to be lib for Libra now, right? And then the things that say Virgo in this cut and paste code, we're just going to change them to be Libra, right? And this is kind of hackish cut and paste code, but it's dead simple, right? And let's not make it more abstract than it needs to be. Yeah, make it as abstract as it actually needs to be. It does not need to be any more abstract than this. So even though this is kind of hackish cut and paste, we're going to stick to our guns and keep on doing it that way for now. Okay, so... we have those, and then the other thing is that we need kind of like these wrappers, right? So file new, and this is going to be called Libra, right? So Libra 1. Save that as Libra 001.scad, and then we're going to take all this code over here, and we're going to call this Libra 02.scad. So so it's just Libra 002.scad, right? So the scad function being called is the exact same name of the file, is the exact same name. So the scad file, the function, and the SVG file all have the exact same name. So it's very easy to come back to this code in a few years and know exactly how to connect the dots, if that makes sense. Like find your way around the code. Okay, so now in here, we want to add the debug code back in, and then we want to create a section for the next cluster of code, right? So Libra code. So we'll call this section Libra code, and we will add what we need to add there, right? So Libra code. Okay, so now that we have this Libra code, we got to make a module, right? So module ZOT.com, so that stands for the namespace is Zodiac table, ZOT, com for component, and this one is going to be Libra, right? It takes a SBC object, which is a shopbot constants object, and then we just need to give this a run, right? Give it a run, and it's not going to do much yet, right? It's just going to show us that wheel, and then from there we will we'll start positioning the geometry within here. So we're going to keep up some stuff for reference. Now I don't know exactly how we want to position this. I'm thinking maybe we want the circle to tangent, the bottom of the circle to tangent the x-axis. Seems like a decent way to go. So let's go into the code here and create a constant section for the next symbol, right? So this is the Libra symbol consts, right? So within here is where we're going to add it. And we're just going to add some basic configuration for the Libra symbol. Now the reason these are top-level variables, rather than embedded into the function, is we may have helper functions that are also going to need to access this, so this is kind of the easiest way to make this happen. Okay, so within here we're going to say ZOT Virgo imp rad equals, we could try 0, we could try 1 or 2. 1 might actually be fine. And what else do we need? I mean, I guess ZOT Virgo imp, and there's no such thing as an imperial radius. It's just a, oh, and I did that there. Well, that was stupid of me, wasn't it? Oh, no, 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 that's right. I'm thinking of an angle. Angles aren't imperial, but radiuses are. Okay, so the length is the length of those lines at the bottom, and I'm going to say that maybe they're like twice as big, maybe like 2.5, something like that. And then we'll just take these things here, right? And we'll go back into here, and we'll create some shorthand variables for those, right? So I don't want to have to type that every single time. So rad and length are going to be equal to these things, right? And we're just going to assume that it's imperial. Even though I made all my shopbot code have the native units being in terms of lugs, but whatever. Let's just get this working. So we got this thing here. We also want to call it, right? We want to call, as we're working on it, we want to see what it looks like. So we'll call this function we're working on right now so that we can see what the results are. Right now, there's nothing, right? So the first thing is we want to create a vcarve inch circle, but there's no such thing as a circle. It's either a wheel or a hole, so it's a wheel in this case. Take the SBC object, and then we need the radius, and then we need a thickness. So a thickness equals, what is the thickness? So if we go up here, we can just steal this declaration here. And then this is the thickness that we're going to use. Okay, so now let's just throw that in there and see how that looks. So that actually looks way too small. So let's go up to where we calculated this radius, right? So this radius right up here. Virgo Imperial. Ooh, hold on. Well, that's the problem. It's because we cut and pasted and we weren't paying attention to what we're doing. So that needs to be called Libra, right? All this stuff is the Libra code, so what the hell are we doing this, right? Not paying attention is what we're doing. Okay, so now F4, that's probably going to get a bit bigger. Is that a good size? It's kind of a good size. I think that'll kind of work for now. And the next question is, like, where do we position this? So I'm thinking we can just tangent it, and that might be good enough. So if we do like a integer, not int y, inch offset y, and we go by 0 plus the radius, and then, yeah, just 0 plus the radius, right? And we just move it up there, like that. That's actually kind of good, because it's close to the top, but not too bad. We could make the circle maybe a little bit bigger, but that'll work for now. And then, where do we want, where do we break this open at, right? What's the correct distance? I don't even know. But what I do know is we just need some 2 lines, and then we just got to put a subtractive piece of geometry, and then we're done. So, so let's create a vcarve inch pocket thingy, right? SBC, and let's use, you know, maybe the radius. Actually, no, we have the length, right? So this is the length we want to use. And then the height, we want to use the thickness, and then for the actual thickness, we're going to make it 0, because the thickness variable is kind of like I regret using it, really. So that is not good enough, right? So the length here, we got to go over here and find that length and say 2 is not quite enough. It almost seems like it might need to be 4, a 1-to-4 ratio. Yeah, like that is actually much better. Okay, so with that, we can say, you know, we're going to take this, and we're going to make it 4 like that. We're going to just say that this is 4 times that, just to establish some type of relationship, a proportional relationship between these things. And then we can go back down here, and we just need to make another one of those. So here's that kind of thing there, and then we just got to go inch y, right, SBC, and then 0 minus 0, right, minus 0 for one of these. And then the other one we'll figure out what the exact offset is, but the first one just stays where it is, right? And if we do that, we're going to see the same exact geometry because both of those lines overlap. And then we need to move it by something. I don't really know what the distance between those lines needs to be. I don't know what will look acceptable. Looking at a whole bunch of designs, I kind of like the idea of the thickness of this line is the gap, right? So I'm thinking that we move it by, if we move it by the thickness, it's going to be tangent, so we got to move it by twice the thickness. So, so I'm going to say 2t, or t2, for thickness times 2, right? So T2 right here is going to equal this thickness times 2, right? And if we do that, let's check out what that looks like. F4. So that looks pretty good. Now, it looks kind of uncentered, but see how close this line is to tangenting here. So we can't really do any better than that, can we? I mean, that looks pretty good, right? If we zoom out, right, it doesn't look too lopsided-ish. It's pretty balanced. So the next part is we just want to subtract the geometry, right? So this is our additive geometry right here, right? So we want to just do like a union difference, union, right, and then difference, and then, right, this is the first union. Then we want to do another union here and encapsulate that in the difference, right? So this is in here. This is the additive geometry, right? And then within here, we want to do some subtractive geometry. So we're going to do a V-carve inch pocket. And for now, we're just going to try like SBC and then like radius, and then 0 for the thickness, and just try something like that and just see what that looks like for now. So F4. So we've made a mistake somewhere. I'm going to guess that the mistake is, oh, right, we can actually see it right there. Okay, that's because, yeah, there we go. Okay, so okay, F4. Okay, so if we look at that, I got to say that's wrong. So first of all, let's just delete this, remove this for a second, and see if, even worse. Everything is... Oh, wait, because union difference, it's a difference with 2 unions inside it. My bad. Okay, F4. So now, let's put this deleter back in, right, and go F4, and take a look at that and say, hey, is that proportionally, is that okay? Or do we want to, put more thought into where that should be, right? Like part of me says that that's okay. Another part of me says, I don't know. So we have the radius. We could subtract using the diameter, right? So if we take, instead of the radius, if on the x we use the diameter for a second, we'll just see how that looks. F4. So the diameter is not a thing. So in the radius, to create a diameter variable, right, we'll just take the radius and we'll multiply by 2, right? So right here, we're going to times it by 2, right? And then from there, we should have kind of a better thing here. Okay, so now let's take a look at that, F4. Okay, so that is, ooh, bad, that's bad. Too far. So radius plus THK maybe, plus the thickness, might look good. Nope, that still kind of goes too far. So the radius is kind of like, cutting in any more than this kind of just looks bad. So we might want to say, well, maybe we want to get it so that it gets to the tangent point here, right? And I don't know how we would do that, except maybe if we move this line up, if we translate these lines up, these lines, we could probably get that to happen. So these are our 2 lines right here, right? Inch pockets, these lines. So I'm thinking, you know, if we move them up by half the thickness, right? So we go inch y SBC, and then we do 0 plus the thickness divided by 2, right? So thickness divided by 2, right? And we move both of those up. We might get something that looks more correct. Ooh, no. That's not what I wanted at all. Those are the wrong lines. Okay. X that out. So F4 for a second. This is all the geometry. So we want to the wheel, everything we want to take, and we just want to move it up, right? So we want to take all this, and we just want to move it up, right? Okay, so take a look at that, F4. And okay, what am I doing? I don't know what I'm doing. Okay, what do we actually want to move up here? So we want to move these 2 lines, right? Well, where are the 2 lines? 2 lines are right here. Okay. We gotta go get food, or at least stop the timer. But why is that wrong? Well, that's the thickness times 2. We actually want the thickness divided by 2. That's what we're doing wrong. Divided by 2. Okay. F4. Okay, we might be onto something not quite right yet. Let's put some breakpoints here. Let's go upstairs and get that food really quick. So I'll be right back. I just gotta get that, or at least turn the timer off. Okay, I'm back. Okay, so if we move that up, it's not quite right. So what is the geometrical? What's the geometrical relationship here? And how do we want to solve that? So we could just, hack it, right? We could hack it and figure out the relationship. So this gap here is based on the cos, right? How big this gap is based on the cos of the angle. If we figure out where this intersection point is, we can figure out how big this needs to be. Where are we around? Where is this point right here? Where is that point? I don't quite know. If we can figure that out, we can figure out the correct subtractive geometry really easily. So it's what would it be? There has to be a formula here. So let's think about it. So to figure out the point right here, to figure out this point right here, it's the cos of some type of angle times some type of radius, right? So the radius is going to be inner radius. The inner radius that we're looking at right now is this imperial radius minus the half of the thickness, right? So this thickness, rad, so rad minus thickness, right? So if we do, the inner rad is the rad minus the thickness, right? And we're trying to figure out this inner radius. We're trying to figure out where this tangency is happening, right? So the cosine times the angle times the inner radius So intersection X hit so the intersection point X is assuming that this is the center right here, that this is the center point, without doing any of the, without assuming that the circle is at the origin right now, right? So eventually we just want the width, so it doesn't matter, because we want to convert the px, py into some type of width. And, right, so cosine and sine, right? And those are eventually going to, we want a thing where we have an angle and an angle, and it's the, instead of an angle here, we want something like a 0, 180, we want 270, right? We want 270 plus angle offset and minus angle offset. So, oops, sorry. So P1X, P1Y. So between here, we're going to make like a funnel, right? And this angle offset is going to be applied to both of these, right? And what we want is we want a thing where the distance on the, we just want to figure out the distance on the x, right? So these formulas, we're doing it kind of both for the x and y right now, but we just want to solve for the x. So after we have this, the distance is, you know, dst, the distance of this, right, or this angle offset. Well, hold on. So we want to know, we want to figure out how big this gap is, but we need to know when the line hits right here, right? Like, so we need to input this intersection, the intersection between this line and the circle, right? It's a line-circle intersection problem. I really don't want to do this because we could just eyeball it and be done here. We could eyeball it and we could be done right now. But I would like to solve this mathematically. So the y-axis, we know that the y needs to be equal to the radius minus the thickness, right? So here's the, from the center to all the way over here. Or maybe not. Oh yeah, why is that not? Why is this going overboard? Oh, it's because the... So we have to know where that is specific to... I don't know if I want to do this. This is just going to be a lot of work for something that we could just kind of hackishly just solve it and just be done with it. Right, we could just make this a little bit bigger, chop off the center there, and just call it a day. I think that's what we're going to do. Let's look at this. Let's just do that, because we're not really going to edit this. It's nice to have it completely parametric, but we're never going to change it, right? If we ever come to the point where we need to make completely parametric things, we could edit that, but for now, maybe we just want to get it done, right? So, because for that to work, then we also have to figure out where this circle is, right? And I actually don't know where this circle is anymore. Like I see it there, but I'm not sure exactly where it is. So, like if we look at the wheel here, it's so we moved it up by the radius, but not the thickness. And that's why it's not tangenting here, because the thickness is The thickness is striding it, right? Okay. So, but it is there, right? So yeah, there's just a lot of complicated calculations that we have to do to get this working. So let's just not do that. Let's just say, let's just hack it, right? Let's just do like rad plus, you know, 0.2 or something, right, on the x. And just make it a little bit bigger, right? F4, right? And let's just keep on guessing and checking. Let's not worry about, so 0.1, how about that? Let's just keep on guessing and checking, because that's gonna be the fastest way to get this done. And we'll just guess and check quite a lot until we get it correct. So 0.1 is a little bit not enough. 0.15 though. Let's try that. F4. That's too much. Okay, 0.12. F4. That's needs to be a little bit more than that. So 0.13. That's too much. That's too much. 0.12. Too much. 1.1. Not enough. So then let's make this a 5. F4. Not enough. Do some more. Almost. So let's go in here a bit. Let's make that 118 for a second. 119. F4. Okay, that's too much. How about a 7? F4. So 7 is way too far. 8. F4. A little bit too far. So we'll make it a 7 and a 5. So 7 and 5. Okay, F4. Okay, how about a 7 and an 8? Alright, we could do this all day. Right? So a 7 and an 8. An 8 is a little bit too far. So how about a 7? F4. 7's not far enough, but 8 is too far, right? Yeah. So 7's not far enough. So we'll do a 7, and then we'll split it in half with the 5, right? F4. Okay, so we're getting really, really close. And yeah, we're almost losing all the precision. So now we gotta go like 1176 maybe. And once we get this close enough visually, then we're done, right? So 1176, 1176 is too far. How about 5? F4. Okay, and then we'll make it a little bit bigger. Let's add a 5. Oops, crap. Lost where I was. Okay, F4. A little bit too far, so how about a 6? F4. How about a 7? F4. Okay, it's way too close to where it doesn't really matter. That last digit, right? Look how zoomed in we are, right? We got it, right? Close enough, right? It's all close enough to where at the level of precision we're using, that's perfect, right? So good enough for me. And then we can just right, we'll just do that, right? And then in the middle, we can do another thing where we do like IY, right? SBC, 0 minus the thickness, and then we'll put another pocket, right? So we'll put another pocket, but the pocket's thickness will just be, the height of it will be, I don't know what the, so the length, so we'll use the length. Do we have a length variable in here? Yeah, so we'll use the length, and then we'll use the thickness, and then we'll use 0. And we want to move it down by, if it's right on here, we want to move it down by half the thickness. So 0 minus thickness divided by 2. Just throw that in there, right? And just be done with it, right? Just, it's done, right? Let's not worry too much about it. That looks good enough to me. Now, should this be the center point or should the circle be the center point? I don't know. But that looks pretty proportional. It kind of fits within the circle pretty well. So we'll stick to that for now, I think. And So we hacked this, so hacked the tangency. So we didn't really know what we were doing. And the time is 0030 23. Yeah, we just hacked this tangency at this video time, right? So that's good enough, right? Good enough. So let's go into here, right? Let's get rid of this thing that we're using for debug, right? And let's ship it, right? Good enough, ship it. Make this a 0. And then what we're going to do is we're going to go find the code, the cutting code, right? Go into the cutting code. And we're looking at Libra, right? So did we make the Libra files? Yeah, we already made the Libra files, so we just got to open them up. And if we've done everything correctly, then we'll just... Are we upside down? Okay, we're upside down. Okay, cool. Export as SVG. And we're just going to call it Libra001.svg. Okay, we're going to close this one. Then we're going to open up the number 2 file, right? Which has... just the pins on the bottom. Export as SVG, and this will be Libra002.svg. Save that. Okay, so now we have the Libra done. I'm satisfied with that. Good enough, right? So the Scorpio actually looks a lot like the Virgo. In fact, it's most of the same kind of geometry. It just has like a little arrowy thing on it. So we should be able to reuse the Virgo code to create the Scorpio code. But before I do that, I want to just commit what I have. I'm going to commit what I have, and I'm going to go take a break to eat food. So let's go close this, and let's go into the cut folder. Let's go find the Libra symbol that we just did, right? So the Libra symbol. And let's go screenshot that and put it into the root of our project so that we have this bigger gallery of what we've been working on, right? And then file, save as, right? And then we're going to save this as libra.png, right? Close it. Close it. Go check that gallery. Also, let's check out everything we have so far, right? So pretty good, right? So this is Aries. This is a crab, so that's Cancer. Gemini, twins, Leo. This is the Libra we just worked on. This is a bull, and a bull would be Taurus. And then this me-looking thing, that's Virgo, okay? So the Virgo is what we're going to use to make Scorpio, right? Because it's so geometrically similar that all we got to do is delete this little tail here, delete this little candy cane. That's what I've been calling it. We're going to delete the candy cane, and then we'll chop this off right here, and then we'll just add an arrow, and then boom, done, right? So that's what we'll do next, but we're going to do that in a different video because we already have this kind of stuff here. But before we do that, let's do a git bash here. Let's commit what we have before we stop the stream. Okay, and so git status. Okay, and then git commit -am. So we have Libra and Virgo. So done Libra, done Virgo. I guess done Virgo is the first thing. Done Virgo, done Libra. Okay. So we have 5 more symbols left. So we're thinking 5 more hours, I guess, if we keep with this kind of consistency, though some of the symbols might take more. Probably 10 hours max, right? If every symbol takes like about 2 hours. But that's an overestimate. That's an overestimate based on how long these other symbols have been taking us. And I think, unless Capricorn is super hard, we've done the hardest stuff so far. So git push GitHub master for a second. I haven't been paying attention, so I may need to do some things before. I may have not committed. I added, but I might have not have already committed. But let's just see if this works, and then we'll stop the stream once this is pushed up. Okay, cool. So that's pushed up. We're going to stop this stream, and then we'll be back later I'm going to eat some food, but then I'll be back later to do the next kind of stuff. So stop streaming.